All right, here we are. Lesson 9, the logarithmic function. We are in Unit 3 of our AP Calculus course, and we are almost done with this unit, so let's keep going. The definition of a logarithm is that y is equal to the log base b of x if and only if x equals b to the y. In other words, if they are inverses. So the log base b of x will evaluate to y as long as raising b to y would give you back x. The logarithm base e is called the natural logarithm. So y equals, where we write L in, the natural log of x, if and only if x is equal to e to the y. The natural logarithm is the inverse of the exponential function. So therefore, the natural log of e to the x must be x, and e to the natural log of x must also be x. And you can go through the proofs and how that works on your own. Let me just give you a quick example that uses a number besides e. So for example, if we said, if we had to evaluate, say, the log base 2 of 8, we need to think, well, what is that? What number, when I raise 2 to that power, gives me 8? And the answer is 3. So that's kind of the same idea. So when I say that, the natural log of e to the third, I'm looking for a number that when I raise e to it, I get e to the third. Well, that's obviously 3. So that's why they kind of cancel each other out and give you that value. All right, so let's graph it. The natural log of 1 is 0 because e to the 0 is 1. So the natural log of 1 is 0. And the graph goes like this and then slowly climbs like so. The domain of this function is limited to just the positive numbers. The log of 0 is not defined. And the range is negative infinity to infinity. All right, so why don't you practice graphing some transformations, pause the video, and practice these. I've got just a couple here. All right, let's see how you did. We know that it goes through 1 normally on the x-axis, but this is going to shift to the left 4. So 1, 2, 3, 4. So it's not going to go through like negative 1, 2, 3. I didn't go far enough. Here it is, negative 4. It's got a vertical asymptote at x equals 0, so now that's going to be at x equals negative 4. So this negative 4 like that. And then the graph will come up like that and then curve like that. All right, the natural log of negative x we know is going to reflect it across the y-axis. So instead of being like this, it's going to be like this. Okay, let's solve. We're going to use our natural logarithm to help us solve this. So I'll take the natural log of each side. Oh, you know what? Practice this first. I kind of gave it away. Pause video. All right. You back? All right, let's do it. I'm going to take the natural log of both sides as a plot twist, right? Natural log of that. Okay. So this becomes the natural log of e will cancel out, give me just x plus 1 is equal to the natural log of 7. So x is equal to the natural log of 7 minus 1. And quite often that's how you have to leave your answer on like a non-calculator portion of the test. But we can actually go ahead and do that right quick. What did we say it was? E to the 7th minus 1. So our answer is, it's natural log of 7. I'm sorry. Natural log of 7. Big difference there. So 0.946. All right, if we have an equation with natural log, though, we can put it as an exponent. So we're kind of exponentiating both sides here. And that will cancel that out, giving me 2x minus 1 equals e to the 5th. So 2x is equal to e to the 5th plus 1. And so x is equal to e to the 5th plus 1 over 2. And again, we can get a numerical answer on that. E to the 5th plus 1 over to 74.707. All right. So we have some pretty important properties, and these properties are going to be really useful to us as we are doing our calculus. So first of all, the natural log of, oh, that is a mistake. Yikes. The natural log of 0 is undefined. The natural log of 1 is 0. That is a typo. The natural log of e is 1 because e to the first power is e. The natural log of a product inside the argument becomes a sum on the outside. So I always say times on the inside, plus on the outside when you split it up. This is called expansion. Likewise, if we have division on the inside, it's subtraction. And we have this power rule that if we have natural log of a to some power, I can bring that power down in front of the logarithm. Let's practice expressing this as a sum or difference of multiple logs. So expand this out as much you can is the idea. So I'll take the top part and I'll write it as x squared plus 3 squared. And then the bottom part is a subtraction. And I will write it as x squared plus 1 to the 1/3. All right, but I can bring these constants out, these exponents out in front, making it 2 times the natural log of x squared plus 3 minus, I'll bring the 1/3 out, the natural log of x squared plus 1. So that expands it out as far as we can. I can't do anything with the plus on the inside, but that actually would make it a lot easier to do calculus on. Sometimes when we're doing algebra, we want to express things as a single logarithm, so we need to be able to go both directions. Usually we're going to expand when we're doing calculus, but contracting for algebra is good. So first thing I'll do is I'll move these coefficients up, make this the natural log of x plus 3 squared. Then I'll make this the natural log of x minus 2 to the 1/2. And then we know that addition on the outside means multiplication on the inside. So this is x plus 3 squared times x minus 2 to the 1/2. All right, so that's our kind of crash course in pre-calculus for logarithms. Let's see what the calculus tells us. The calculus says that the derivative of the natural log of x is 1 over x. The chain rule version of that is the natural log of u is u prime over u. I write it here 1 over u times du dx, but I always think of it this way when I'm trying to calculate. It's the derivative of the u over itself. All right, well, let's prove it. This is an easy proof. We're not going to wait till the end. We're going to go right to this one. So for the proof, the natural logarithm is just a simple application of our derivative of an inverse. The logarithm is an inverse of an exponential. So we know that if f of x is e to the x, then by definition, f inverse of x would be the natural log of x. And f inverse prime of x is equal to 1 over f prime of f inverse of x. Right? So let's figure that out. We're trying to find f inverse prime of x, where f is e to the x. Well, what is f inverse of e to the x? Well, that's natural log of x. I gave it right here. So this is really just 1 over f prime of the natural log of x, right? Well, what is f prime? Well, we got to take the derivative of f. So remember, f of x was e to the x. So f prime of x is e to the x. So this is 1 over e to the natural log of x. Because I'm doing f prime of natural log of x, which I got to put this right here. But e to the natural log of x, that just cancels out. So this is just 1 over x. Piece of cake. All right, let's find the derivative of each. F of x equals the natural log of 2x. The derivative is u prime over u. So u prime is 2 over u, which is 2x. And we could leave it like that. We could also simplify it, and we get 1 over x. Well, wait a minute. Did that 2 even matter? That's a good question. Maybe we could do this a different way. Well, if I expand this, can't I expand this and say this is equal to the natural log of 2 plus the natural log of x? And natural log of 2, isn't that just a constant? And the derivative of a constant is 0. So this is just 1 over x. The derivative of the natural log is 1 over x. So you see we could get it in two different ways, but it's really interesting. You see that constant multiplier in the middle there becomes just like a constant. Constants behave strangely with natural log. All right, let's try the next one. Okay, no little tricks I can do here. I can't expand this. Natural log of u, the derivative is u prime 2x over u, x squared plus 1. All right, on the next one, we're going to use the product rule. Derivative of the first times the second plus the first times derivative of the second, which is u prime over u. But that reduces. Now, again, we have not been emphasizing simplifying, but I just think these problems are neat, so I like to kind of take it just a little further just to kind of see that that's kind of a cool result for x times the natural log of x. All right, your turn. Do these practice problems. Pause the video. If you don't have all these problems in front of you, you can just pause it in sequence as we do each one. All right, so let's go over what you got. So f prime of x is equal to u prime over u. The derivative of secant is secant tangent u and over u. Well, that's weird. That's just tangent of x. So that's kind of cool, right? That the natural log of secant of x is tangent. The derivative of natural log of secant x is just tangent x. All right, let's try the next one. Y is equal to the natural log of the square root of x plus 1. I'm going to rewrite that as the natural log of x plus 1 to the 1/2. But it would behoove us to rewrite that as 1/2 times natural log of x plus 1. If you didn't, you can still get the right answer, or it might just look very different than mine. So the constant comes along for the ride, and the derivative of x plus 1 is u prime over u. So it becomes something like that. And make sure you realize those are two different fractions. So if you multiplied them, it would be 1 over 2x plus 2. All right, I've got the natural log of x. So the derivative of that is u prime. All right, so here's my u. U prime, well, what's the derivative of that? 1 over x. Over u. And that becomes, if I divide that, it goes to the denominator, x natural log of x. So that's kind of a weird result as well. Again, I'm simplifying only because they're interesting. I'm not emphasizing that right now for you. All right, we got just a couple more here to do. All right, y prime. Bring down the exponent. 3 times the natural log of x squared times the derivative of the inside, which is u prime over u. Don't try and bring that exponent down, because that's only if the 3 was on the x. I mean, I brought it down in the derivative, but I mean, don't try and use log expansion here, because that's natural log of x, and that whole thing is cubed, not natural log of x, where only the x is cubed. Cosecant of natural log of x. The derivative of cosecant u is negative cosecant u. Cotangent u. I cannot read that. What is going on here? Cosecant u. Cotangent u. That's better. Times u prime. All right. That's it. Well, I hope you enjoyed learning about the natural log of x. So, until the next lesson, take care.